Welcome back. Page 2 of this assignment. This is probably one of the more important pages in the entire chapter because with this particular page, we deal with factoring out factors that don't look like factors. You can see in number 27, we've gone ahead and highlighted what's common between these two different terms. So I think it's important to go back and talk about what's a term and what's a factor. Because you have factor written here as a verb, but you also have factors as a noun that are things that we multiply. We call terms, we can call them anything that we add and subtract. And it's a simple definition, but it's effective here because terms are what we add and subtract, and factors are what we multiply and divide. And you look at this and you think, well, x plus 2 must be a term because it has a plus sign with it. But if you step back and look at the big picture, we have a 3 times something minus an x times that same something. Think about the first variable you ever learned was. Do you remember what the first variable you learned was?
The very first variable I ever learned was probably x, or a.
Go back before that.
I
bet you can go even before that. Go back to second grade.
Second grade. Well, would it be a numeral?
Even before that.
Gosh, a plus sign?
Well, plus signs usually had these things to the left or right of them, and you had to fill in.
Oh, the blank.
The blank.
Oh, yeah, the blank with the question mark in it.
Or probably the favorite, the empty box that was just big enough to write in. So.
Gosh, that was so long ago, I completely forgot about those.
Did you know you were learning algebra back then?
I had no idea.
So this is what we're looking at. We're at 3 times a box minus x times a box. And that's the same problem as we see in number 27. Or I can make it 3 times question mark minus x times question mark. That can get a little confusing.
Sure.
But essentially, we're looking for a greatest common factor between this thing here on the left and this thing here on the right. So what do you think our first step is now?
Well, as I'm looking at this, since we have 3 times a box, and then that box is the x plus 2, minus x times a box, and that same box is the x plus 2, I'm guessing that we would probably have to do some sort of undistribute, where we take that box and we bring it out in the front.
So let's look at the box version we have here. If I pull the box out and erase this to kind of get this out of the way, what I end up with is a box, and I'll even throw the little green highlight in, times, and what we have left is whatever's remaining, 3 minus the x. And this would be our factored form. Now, can we translate that to number 27?
Yeah, I think we can, because since that box represents the x plus 2, we would probably have x plus 2 in parentheses, and then in the second set of parentheses, we would have 3 minus x.
So let's look at this for just a second. So if we look at what's left, we have x plus 2 and 3 minus x. And it's not immediately obvious that that is the factored form of what we see here on the left. But think about how we first learned to multiply two binomials by each other. We would take the x plus 2 and multiply it to the 3, and then we take the x plus 2 and multiply it to the x. If I were to do that, now keep in mind that our answer, our factored form, is what we have here. What we're doing right now is we're checking. And if we go and we multiply those in, we should have 3 times x plus 2 minus x times x plus 2. And that's what we see here.
So it's kind of like when we require the kids to show their work, this would be what you've written here, where it says 3 times x plus 2 minus x times x plus 2. That would be like the intermediate step between the first part, where we're supposed to multiply those two binomials together, and the last part, which is where we would simplify everything out.
Right. So look at number 27 again. This is not a simplified form. This is also not a factored form. It's an intermediate or in-between step. It's just something that we'll kind of hit along the way. You're learning a skill right now that we're going to be using later, which we can call undistributing, or we can call factoring by greatest common factor. Let's go on to 28 and see if you get the hang of this. On the left side,
I see 5y times the parentheses y squared plus 3. And then I also see minus, and then in parentheses, y squared plus 3. Now looking at that, the very first thing that hits my mind is y squared plus 3 shows up in parentheses in both of those terms, and we call them terms because we add those things together. In this case, we're subtracting. So I'm guessing that this form looks a lot like 27, but there's nothing, or is there, that we are multiplying the second term by.
So let me try. If I pull this out, I have a y squared plus 3, and then just a 5y, because there's like a minus nothing. Is that right?
That doesn't seem quite right, because if we were to put that back through, y squared plus 3 times 0 would just be nothing, and we wouldn't have a second term. So there must have been something that we multiplied it by to get that second part. So what multiplied by, what would we have to multiply y squared plus 3 by to get y squared plus 3?
Well, anything times 1 is that thing. So if I do a plus 1, oh, wait a minute.
Oh, dang it, it's a minus sign.
It's a minus. So let's change that to a minus 1. Okay, now that makes sense. And if we look back here, we also could write in, there should be an invisible coefficient here.
Oh, yeah.
Of a 1. So really we see a 5y minus 1, and then the y squared plus 3 that we factored out. Now, what looks to remain here, we have two binomials, and a lot of people ask the question, why are there not two of these? I mean, if you pull this out, why are there not two of those?
Oh, yeah, I see what you're saying. Why aren't there two of those?
Well, we just did a whole 25 minutes of 26 problems right above, and we never took out two of something. We always took out one copy of it. This should be no different than that. Let's go on to 29. This one looks to be a little bit easier.
Yeah, as a matter of fact, I think I might be able to work this out on my own. May I try the pen?
Uh-huh.
Okay. As I look at this, I notice that both terms have this x minus 2 again. Let's see if I can find the highlighter. Where is it? Up. There we go. I'll just use green. And so I notice that this is an x minus 2 and this is an x minus 2. So much like in the previous examples, I think what I can probably do is I can probably just take that x minus 2 out and put it out in front. And then what I would be left with in the back would be 4x from the first term and plus 3 from the second term. So I think that when I do that, I should get x minus 2, the quantity x minus 2, multiplied by the quantity 4x plus 3. How did I do?
You look great. You're writing so much better than mine. Okay. Lastly, we got x minus 5 in both. Let's just take that and pull it out in front, and then what's left?
I believe that would be a y squared plus 6.
And that's it.
So would you say that recognizing this form is the biggest part of learning how to factor?
I would absolutely agree with that. It's not that you can't do these if you see a whole pattern. Think about taking this entire section out of context. Like if you saw that and it just said factor and we hadn't just done, a bunch of these. That's where you have to kind of see this is a strategy. It's called greatest common factor, but in all of these we have multiple groups. And the thing that helps us remember that is this plus sign that's here, this plus sign here, this minus sign here, and that minus sign there. All of those help us see that it's not quite a factored form yet. It looks factored, but it's not yet. Not until we get to a place where everything is being multiplied by itself. Here's a factor, here's a factor, here's a times sign.
So we're always looking to have terms that are multiplied together so that there isn't a plus sign in between these guys, so that we are dealing only with factors and not terms.
Right. Everything has to be multiplied. Number 31, kind of on down, is just a little bit of practice. We can call this going the other way. This is sort of the opposite direction. This says multiply, which is the opposite of factor.
That's an important thing to learn, isn't it?
Yeah. There's one other direction set that we could use. We could say multiply, which tells you a little bit more directly what to do. We could also say simplify. It's important to know that when you factor, you're not simplifying. You're actually making things a little bit more complicated. If you look at number 30, certainly the factored form looks simple, but it's not multiplied out. 31 is a factored form, and we want to take it and we want to multiply it. So?
All right, well, let's see. Probably what I would do is, since the two terms are not the same, I would probably end up foiling this. So my first term is going to be 2x times 3x, which is 6x squared. And then my outers is going to be 2x times negative 5, so that's minus 10x. My inners would be 1 times 3x, so plus 3x. And my lasts are going to be 1 times minus 5, so that's just minus 5. And then we have to collect like terms. So my final answer is going to be 6x squared minus 7x minus 5.
I agree. The trick would be, could you go from here to here?
Oh, now that takes a little bit more practice.
Yep, we'll be doing that in a little bit here, guys. So let's kind of go through. Feel free to pause and work your way ahead. Remember, 28x squared. Outer would be minus 4x. Inner would be minus 35x. And last would be plus 5. And then we end up with 28x squared minus 39x plus 5.
Ooh, look at this next one. This is a 5x plus 3 multiplied by itself. I think the answer is going to end up being a perfect square trinomial.
Really? You can't just go 25x squared plus 9?
No, of course,
Oh.
that would be a sum of two squares, and that's never something. So
Okay.
I remember that.
I just saw my friend do that.
Ugh, I hope you corrected him.
What about just kind of erasing that 2 and writing it by itself?
You could do that, and there's nothing wrong with that. It works the same way as every other thing that we've done. So we can certainly just write it by itself and FOIL it out if we don't recognize the form for a perfect square trinomial.
Do you think some of these guys have gotten to the point where they can just recognize the form?
I would hope so, but even if they don't, it's nice to know that we have something to fall back on.
We do. So, you want to take over? So
Yeah.
you know what you're doing.
So let's see, if this is a perfect square trinomial, then what I'll end up with is first squared plus twice the product of the two plus last squared. So here's my first, 5x, and that squared is going to be 25x squared. Twice the product would be 2 times 5x times 3, which is 15x times 2, which is 30x. And then the last squared would be plus 9. So if I remember what the perfect square trinomial form is, I can do this really, really quickly. Oh, I forgot my x.
And we dropped the pen.
And we dropped the pen. Found the pen, and here's the x. It was hiding.
Okay, so let me try this. 7x squared becomes 49x squared. Got a minus, so it would be minus 2 times the product of 9 and 7. So 2 times 9 and 7. 9 times 7 is 63. 63 times 2. Don't ever be afraid to cheat on the left side. It's the smarter ones. Oh, that's not 9. That's 6. It's the smarter ones that do this, so they know what or they get this right. Okay, 186x plus, and then 9 times 9, 81.
63 times 3? 3 times 3 is...
Oh, I should be a 2.
And I think 3 times 3 is 9, isn't it?
That's 63 times 2.
Oh, 63 times 2. I'm sorry.
That's okay. Okay, double check. Looks good to me.
Yep. All right. Good deal.
Okay, 35. I see something like this, and I go order of operations. We want to do the x plus 1 squared first, and then multiply by the 3.
Yeah, we're going to expand this out. There's really 3 factors here, aren't there?
There are. There's a 3, an x plus 1, and another x plus 1. So while it doesn't matter the order we multiply them in, I think it's easier to go x plus 1 squared first.
Definitely.
So let's go x squared plus 2 times 1 times x plus 1.
And then we still have to multiply it by that 3 out front.
Yep, so let's keep that in parentheses and distribute. 3x squared plus 6x plus 3. Want to take over?
Yeah, let me try this one. There are 2 different binomials here, so I'm going to go ahead and FOIL. So we get 4x times 2x is 8x squared minus 10x. Oops, I did the inners first, but you don't really have to pay attention to that. 4x plus 7 is plus 28x. And then minus 5 times 7 is minus 35. So what we're looking at here is 8x squared. Let's see if I can remember to put the x in this time. Plus 18x minus 35. And then, because I went a little fast there, I'm going to go ahead and check my work real quick just to make sure that I didn't make any mistakes. And it looks good to me.
So what he did there, you could do was a FEAL, which is always fine. FEAL, FOIL. Remember, the order of those letters can actually switch depending on what you want.
Absolutely.
We tend to do FOIL or FEAL or do this with the middle terms because then we get a nice polynomial in descending order.
Yes.
39 and 38, or 37 and 38, if you recognize what these are with a plus and minus in what's otherwise identical binomials, we call these conjugates.
Oh yes, I've seen that word before.
And when you multiply 2 conjugates together, you leave a very hard to find candy in bulk. You guys should appreciate how hard it is to find lots of these.
It's not easy.
But difference of two squares. So for my first, 9x squared, my outer would be plus 6xy, my inner would be minus 6xy. Those are going to cancel and drop out. And if you recognize that, we don't even need to write them. Minus 4y squared. Your life will be a little bit easier in this chapter if you can get to the point where, with the perfect square trinomials, you can go directly to that form. Oh, sorry, not that form. You can go directly to the perfect square trinomial form, and with the dots, the conjugates, you go directly to the difference of two squares form.
It saves a lot of time, and it also helps with your factoring later on.
So, want to end it up?
Yeah.
Create.
It looks like we have another example of these conjugate pairs where I have a 9x and a 9x and then minus 25y squared and plus 25y squared. So once again, I know that this is going to be a difference of two squares. It's going to have the form a squared minus b squared. That's how you can tell that you have a difference of two squares, because it's a difference of two squares. So we're going to have 81x squared, and then minus, and then 25 squared is 625, and then y squared squared is y to the fourth. So our answer is 81x squared minus 625y to the fourth. But don't try and do these things in your head if you don't want to. Feel free to multiply out the 25 times 25. No one's going to laugh. That's important. 10, 12, 10, 5, 625. Whew, I got it right.
One little thing to note, calculators are not going to be allowed in this chapter on tests and quizzes. So you will want to multiply stuff out if you really need to do it by hand. And again, no one will laugh. We'll laugh when you don't do that and just try to guess or do something ridiculous. So,
That's a good point, yeah.
Okay, homework's a worksheet, and good luck. Remember, you can return to this video anytime you want to see any of these problems done out.
See you tomorrow.